So let's do a quick recap on what we did last week. So last week we looked at the MATLAB basics, and mainly we looked at variables and assignment operator. So with variables, if you recall, the way MATLAB works, or any programming language works, is you need to define, or you need to put information in a variable. So for example, in MATLAB, you can create a variable called a, and you store the number 3 into that variable. So what MATLAB will do is, MATLAB will remember that a contains a variable 3. Now, you can use that variable to do any operation that you want. So for instance, you can also say b equals to a. So now MATLAB has two variables. So it has a equals to 3, and it also has b equals to a, which means b at the moment equals to 3. So then you have b equals to b plus 1. So from last week, so the new variable b equals to the old variable b, which is 3 plus 1, and now this becomes 4. So now MATLAB forgets about this one. It replaces that with b equals to 4. And then it will now replace a with 4 plus 3 multiplied by 3. And you have the order precedence. So the way that MATLAB will do calculations, so BODMAS, brackets first, order, division, multiplication, addition and subtraction. You also have a bunch of inbuilt functions. And again, during the labs this week, you would have a chance to look at a few of those inbuilt functions. You can use, for example, square root if you want to solve a question on Pythagoras theorem. So today what we're going to focus on is matrix. Now, a matrix is basically an extension of a variable, in a sense. So, like we said, a variable will contain information. But so far, or from last week, what we've looked at is a variable that contains only one information, or only one number. So even for the labs this week, the variables that you have, so whether it's a, b, c, d, distance, height, etc., all of them contains just one value, or one piece of information. A matrix, on the other hand, is basically a variable that can contain many values. So for instance, a matrix, you can have a matrix A that contains the values of 2, 3, 5, 7. So that's a matrix. So it's a variable A, but that contains multiple values. In actual fact, MATLAB actually stands for Matrix Laboratory. So MATLAB has been developed mainly for solving problems with using matrices. So compared to other programs, again, as you will probably learn a bit later, but other programming languages, they can use matrices, but they also use different methodologies to solve problems, like examples such as loops. But MATLAB, it can, again, use all these other methodologies, but it's been built to work with matrices in a very efficient manner. The reason for this is matrices are used a lot in engineering and science. So matrices, again, they are usually called, or often called, arrays in programming. For our case, we're going to define arrays and matrices as arrays being one-dimensional and matrices being two-dimensional. What I mean by that is, so an array will be A equals to some numbers, let's say 2, 3, 4. So that's one-dimensional because you have one row and you have 3 columns. One-dimensional will also be A equals to 1 column and multiple rows. A matrix will be multiple rows, multiple columns. For example, So that's a 2 by 2 matrix. So we'll also call like the array. So for Eng1060, so we have here vectors. So again, it's just a 1D matrix. A black and white image. So again, these bits here, we won't really cover that much into the course, but a black and white image is effectively a 2D matrix, and a color image is 3-dimensional. Give you some examples of where you use matrices. So engineers have to deal with large and complex numbers, or complex problems. So just for example, a 2-minute audio file will contain approximately 6 million data points. Image processing, so 3-megapixel color image will contain 9 million data points. And now you have cameras that come up with 10 megapixels. So you can do the math to see how many data it's processing, or it has to process. So in a number of applications, you tend to use matrices. So if you're working with images, so that's a lot of data. But you can also work with more discrete data. So you do an experiment in engineering. You're recording the velocity of a car at different times. So you end up with a set of values for time and a set of values for velocity. So that is basically a matrix. So an example as well is for the hawk's eye. So that's used in the tennis video referee. So let's imagine when you're using the hawk's eye system, you've got 10 cameras that are looking on the court. If each camera has 1,000 frames per second, so they will take 1,000 images per second. Let's say the resolution is about 1.3 megapixel. So in essence, you have 1.3 times 10 to the power 10 data points per second to be processed by the computers. So this is basically used to track the trajectory of the ball. So you take the photos at each second of where the ball is going, and you can predict where the ball will land. So let's look at how to create the matrices. So we'll look at how to create a vector to start with. So for instance, if we want to create vector A that contains numbers 1, 2, 3, 4, so in MATLAB, what we'll do is we have A equals to, you open up a square bracket and you type in the numbers in the vector by leaving a space between them. Okay, so that will create a row vector that contains the number, in this case, 1, 2, 3, 4. You can do the same thing by, instead of having a space, you can put a comma. So 1, 2, 3, 4. So you can separate it by comma or spaces. It will do the same thing. However, if you have to make a row vector that contains values from 1 to 100, or in this case 1 to 20, you don't have to type in all the numbers one by one. So MATLAB, or the computers, can do the repetitive work for us. So in this case, MATLAB has a sort of an inbuilt function or inbuilt command, which is the colon operator, basically this, that can create a vector that are evenly spaced, so equally spaced. So let's try that. So if we want to create A equals to 1 to 20, let's just do 1 to 10 for the moment. So now MATLAB creates a vector A from 1 to 10 that are evenly spaced. So notice here that you don't need the square bracket. So you only need the square bracket when you're directly inputting the values into the vector or matrix. Yep.
How do
Yep, you can. So if you want to change what the spacing is, so the default spacing is 1. If you want to change what the spacing is, then you start, for example, with 1. Okay, you can start with anything, colon, then you specify the spacing, and then colon, 10. So now that will go in increments of 2 until 10. So in this case, you will see that it doesn't actually hit 10, because it will go 1, 3, 5, 7, 9, and then it tries to go and in an increment of 2, which will make it 11, but you only want to stop at 10. So you can do 0.5. Okay? And again, so now if, let's say you're writing a code, and you end up writing just a bunch of lines, or you're writing like a big matrix, but when you're actually writing the code, the output that you want, it could just be one answer, or just a bunch of answers. So you don't want to print every single thing that you write onto the command window. Now, some of you who've had the labs yesterday would have gone through that already. The rest, you would do that during the week in your lab. But one way to suppress your output, so when you write an M file, so you write every line, but when you run the code, if you don't want each and every line to show up in the command window, you can suppress that line by using a semicolon. Okay, so you'll do a bit more of that in your labs this week. So what we looked at just now was creating a row vector. Now we look at creating a column vector. Okay. So first, let's clear this. So if we want to create A, again, that contains the number 1, 2, 3, 4, but we want to create that as a column vector. The syntax is A equals, open up the square bracket. So you still have you can do the direct input, so you have your numbers in there, but now you need to separate the numbers using a semicolon. So you have 1, semicolon 2, 3, 4. So now what you end up is a column vector. So that is for the direct input. If you have to create a large vector, that is, for example, equally spaced, so as before, we had A equals to 1 to 10. Okay, so that will give us like this. We can do A, and then we do the transpose. So if we put that little apostrophe sign after the A, it's called transpose. So what that does is it switches a vector from a row to a column, or from a column to a row. So all it does is just switches between rows and columns. Okay. So if you can write that in just one command. So just now I wrote A first, and then I put A transpose. You can write that in one command by just using the round brackets and then transposing it straight away. And as we discussed before, you can also set the increment size. So the MATLAB default will be 1. So whenever you use a colon operator, by default, MATLAB will use an increment of 1. However, you can set the increment size to whatever you want by this syntax that we showed before. So let's say you have to create this matrix in MATLAB without typing all the values. So what you need to do is, when you look at the matrix, the first thing you'll see is it's a column vector. So that means we're going to have to be A equals to something transpose. Now, what's in that vector? You can see it's going 3, 2.5, 2, 1.5, 1. So it's going down by an increment of 0.5. So therefore, it's starting at 3. It's going down by 0.5, so negative 0.5, until the last value is 1. And all of this transpose. So that should give you this number. I'll let you guys try this one out. Now, let's imagine you're working for a company that installs street lamps. So one of your jobs is they want to put lamps on a street, and they want it to be spread out in 20-meter intervals along that street. So fortunately for you, the street is 400 meters long. So you can basically decide where should I put the post by creating a vector that goes from x, starting at 0, in increments of 20 meters, up until 400. So that will give you all the distances where you need to put the spacings or where your post has to be. However, not every road is 400 meters. So you work for the same company. However, now what they say is, well, we've got 23 lamps, and we want to put that onto a street, and we want it to be evenly spaced. So you go out to the street, you measure it, and it's 525 meters. But you have 23 lamps to space out evenly into that. How do you do that? Simple mathematics. So we have the street length, 525, number of lamps, N23. So here we're using variables L and N to store information about the street length, and we're storing information about the number of lamps. The separation between the lamps is L divided by N minus 1. So N minus 1 is the number of intervals. Because imagine if you have 1, 2, and 3 lamps. So if you have 3 lamps, you will only have 2 intervals. So 23 lamps, that will mean you have 22 intervals. So you do the calculation 525 divided by 22. So that will tell you that your spacing, here given by the variable s, will be 23.86 meters. So now you can create the spreadsheet or the vector that will contain information about the distance that the street lamps have to be set apart. So you will go to 0, S, this is S, 5 to 5. And that will give you something like this. Yeah? Now, luckily for us, somebody has created an inbuilt function in MATLAB that will do this for us in one line. So so basically what you are doing here as a mathematics, somebody has put that into a code, made it into like an inbuilt function, and they call that function linspace, which stands for linearly spaced. So again, if you've had a look at the labs for this week, in task 1, you would see there's one part of task 1 that requires you to use linspace. So here's an example of where it works. So what linspace does is you specify the first value, the last value, and the number of values that you want between the start and the end, including A and B, or including the first and second one, last one. So in this case, what we specify is x equals to linspace 0, 5 to 5, start and end, and how many values we want in that vector x. So what linspace will do now, it will create a vector called x. It will put 23 values that are equally spaced between 0 and 5 to 5. So again, you will get a chance to try that in the labs this week. So now, go on to 2D matrices. So 2D 2D matrices work very similarly to a vector, just that the matrix itself is bigger, contains multiple rows and multiple columns. So again, you can create a 2D matrix by directly inputting the numbers. You can use a space or commas to shift between the numbers in one row. If you want to change row, so you want to go to second row, you use the semicolon. So let's do that. So A equals to, so 1, 2, 3, semicolon, 4, 5, 6, semicolon, 7, 8, 9. That will give me a matrix that has 3 rows, and so it contains the number 1, 2, 3, 4, 5, 6, 7, 8, 9. You can also use the colon operator, just like we did for vectors, to create 2D matrices. Again, if you're using colon operator, it must be evenly spaced. So the colon operator will only work to create evenly spaced numbers. So if you're creating the matrix A like above, so you'll use 1, 2, 3, as in 1 colon 3, semicolon 7 colon 9. And that will create that vector. You can also use a previously created vector to make a 2D matrix. Or you can use a vector to make another vector. For example, if we have B equals to 1 colon 3, so basically B equals to 1, 2, and 3. So B is a variable that contains some form of information. In this case, that information is a vector. You can use that information into another vector. So you can now create a vector A, where you have the first part, or the first row, is the elements of vector B, and then the second row is 7 to 9, and the third row contains these numbers. So you can mix and match. So you can see here, we're addressing a vector from before. We're using the colon operator, and we're also using direct input. So you can mix and match the different ways of creating vectors to write a vector that you need. You can also concatenate a vector to make a bigger one, or a matrix as well. So what this means is basically just putting 2 vectors together. So if you have A equals to 1, 2, 3, 4, and B equals to 5, 6, 7, 8, you can have a vector C, whereby you write A and B. So what that does is it will join the 2 vectors together. So C will become 1, 2, 3, 4, 5, 6, 7, 8 as one vector. So it just combines them together. If one of the important things when you work with matrices, is especially when you're putting 2 matrices together, or you're doing operations with 2 matrices, generally speaking, the dimension of the matrix has to match. So for example, if you have 8 and 9 here, and you try to concatenate that, it won't work, because they're not the same dimension. So for matrices to operate, all the matrices that you use generally must be the same size when you're doing any arithmetics between them. So MATLAB has some built-in functions for creating matrices. We've given you 4 examples there. So you have zeros, ones, I, and rand, R-A-N-D, random. So zeros will create an empty matrix. So it will create a matrix that contains just a bunch of zeros. So you specify how many rows, how many columns, and it will create a matrix that has a bunch of zeros. Why do we need this? Is to save or to be more efficient in the way we run the code. So for instance, let's say you're doing some form of calculation, and you're going to store that information in a matrix. if MATLAB doesn't know what is the size of the matrix, by default, it will allocate a certain amount of memory for that matrix because it doesn't know what size it is. And that size will keep changing. So it will start with a 1 by 1 matrix. Then it realizes that you're putting more numbers into it. So it increases the size. And then you put more numbers, keeps increasing the size. So it allocates a lot of memory to do that task. However, if you, beforehand you predefine a matrix, so before you start the code itself, or before you do that calculation, you tell MATLAB that whatever code that I will be doing, it will be stored in a matrix that is a 3 by 4. So let's say you're going to put 12 values. So MATLAB uses a little bit of memory to create an empty matrix, but then it already knows what's the final size. So it doesn't have to waste memory to alter the size later on. So this, again, it makes a big difference when you're working with images that contains like millions of data points by pre-allocating a matrix. Once, so just like we did for zeros, it will create a matrix now that contains a bunch of numbers that, or whatever size of the matrix, and every single one is contained as a 1. So by default, it's 1, and then as you do the calculation, it replaces the 1. Then you have I. So the I of a matrix is basically a matrix that has the diagonals 1, and everything else is zeros. And random, it will just create a matrix containing random numbers. So some of them you will use later on in the course, especially when you come to the second half, doing numerical methods. Because when you do numerical methods, and quite often you will be using a lot of matrices, and you will come across especially those three, not so much the random one. You can also find out about the matrix properties. So let's say you have a matrix, or you write one, you're given one. You can find the longest side of the matrix. Yeah.
When I do rand, it only comes out at like 0 point something. Why doesn't it come out as a whole number?
Because I think this command here doesn't give you the integer. It just gives you the random numbers below 1. Yeah. I think there's another command to give you integers as well. So the longest side of a matrix, so if you have a matrix that's 3 rows and 4 columns, so by using the syntax length, it will give you the longest side of the matrix. It will give you 4. Length is also handy to use on a vector. So if you have a vector that contains, I don't know, like 200 numbers, but you don't know that it contains 200 numbers. Because, for instance, that data could have just been given to you. So you are loading that data in MATLAB, but you're not going to count how many values is in there by hand. So what you do is you use the command length, and it will tell you how many values are in that vector. The command size will give you the size of the matrix. So size will give you the rows and the columns, whereas length, if it's a vector, it will give you how many values are in it. If it's a matrix, length will give you the longest side of the matrix. So let's say you have now a matrix A. So A contains some form of numbers, in this case 2, 4, 6, 8. You can get a submatrix from a larger matrix. Or you can basically, what we call that is matrix addressing. So effectively, if you have A equals to 2, 4, 6, 8, and you want to extract the first value of that matrix, you use the command A using the round brackets. So A1 will extract the first value of A. A3 will extract the third value of the vector A. when you extract values, so the example that we looked at before, they were just extracting one value each. Okay, so you're extracting the first or the third, etc. However, from a large matrix or a large vector, you can extract multiple values. So you can extract like a submatrix. For instance, for a given matrix A, you can use A round brackets 1 to 3. So that will give you the first 3 values of matrix A. Yep. Yes, you can directly change the vector, although in this case it will be more like creating the vector. So like we had before, this one here. So you can directly change the vector by using other vectors. If you want to find specific numbers from a vector, but this one here was finding the first 3 vectors, but what if you want the first, the 5th, the 10th number of a vector? You can use the direct addressing. So for instance, in this case, we have A. We still use our round brackets. But remember, even from before, when you create a matrix, if you want to create a matrix using direct input, you need to use square brackets. So when you're addressing using direct input, you still use square brackets. So you have your round brackets. That's going to be addressing A. And the square brackets, so we'll get the 3rd, 4, and 2. So the 3rd number, the 4th number, and the 2nd number. And that will give you your new matrix. You can have a matrix addressing another matrix. So if this matrix B is 3 to 1, A of B, that means it will look for the 3rd, the 2nd, and the first value of A. This you will use quite often, especially for next week's in the lab. There's a question about finding, for example, a maximum or minimum. Now let's imagine you have X and Y. Okay, let's say this is plotting the trajectory of a ball. So you throw a ball upwards, so the ball will probably go something like that. So then it will start to fall down. So X is the horizontal distance, and Y is the vertical distance or the height that the ball reaches. So when you throw the ball, there will be some part that the ball will reach a maximum distance. If you want to know what is the value of X that corresponds to the maximum height that the ball reaches. So let's assume that you have X given to you between 0 and 10 meters. So, and you have an equation for Y. In this case, let's call it x squared plus 2x plus 4. Okay, just random. So using the values of X, you can calculate the values of Y. Now, if you need to plot that trajectory, or you need to calculate that trajectory, the first thing you need to do is you need to create a set of values for X. So you could create 0 in increments of 1 to 10. But this will give you only 11 data points. So you can, since the computer is doing that for you, you can make it 0 in increments of 0.0001 until 10. So create like 10,000 data points. Doesn't matter. The computer is working it out for us. So then we calculate the corresponding Y. So what will end up is a vector X that contains sort of a bunch of values, and a vector Y that also contains a bunch of values. So what we can do now, we can use a command called max. or min. So this is an inbuilt command. So you can guess what this command will do. So this will find the maximum of a vector. So if we do the max of y, it will give us the maximum value of y. We can also use that same command to give us the index of that maximum value. So let's say the maximum value of y occurred here. And this was the 12th value in that vector. So using the max command, we can extract that 12th value. Then we can look for the corresponding 12th value in X. Yep.
So how do you know it's the 12th value? Does it give you what value it is or what
Yep.
number it is?
It will give you both. So let's have a look at this. So let's say we have A equals 2. So 2, 4, 7, 6, 1. Okay? So in this case, you know that the maximum value is 7. So if you write B equals to max of A, so if that works well, that should give us 7. But it doesn't tell us it's the third value yet. So the same command max. So here, what we've written as B is our output. So what we are extracting from the command max. So when you do the help on max, so you can see here, it tells you the max of X returns the indices of the maximum values. But for it to do that, you have to write it in that syntax. So you have to tell MATLAB that you want 2 outputs from that. And by default, or not by default, but the way that code max will work, it will know that the 2 values that it needs, one of them is maximum, the other one is the index. So let's try that. So that's A. So B, and then we'll just write index. So we know, again, it can be anything. It can be any variable. So now it tells us that the maximum value is 7, and the index is 3. So if X was 1, 2, 3, 4, 5, 6, and then A was so that was A. So you can find the B index, which is the maximum of A, and it tells you it's the third value. And you can also find X of the index. So that will be X of 3. So in this case, it's 3 itself. So this comes in handy when you need to find corresponding values between matrices. But the reason I just did this example here is there's a question like this in the lab for next week. So the lab for next week, the question is, you have a bridge or a beam, and you put a load on that beam, so the beam will deflect. So you want to find what's the maximum deflection, and at what distance along the beam does the maximum deflection occur. If you put 2 loads, for example, it will change the shape of the deflection, and it will change the distance where the maximum deflection occurs. So this can come in handy if you have a big truck sitting here, and you have another big truck sitting there. Okay? I know it won't deflect like a huge amount, but still, these are examples where this can come in handy. So when you're designing the bridge, you would design it to look at the maximum deflection and make sure you're accounting for those scenarios. You can also use, there's a few keywords that you can use when you work with matrices. You have the AND keyword. So if you have vector or a matrix, so you have, for example, A is this. A(n) will give you the last value of that matrix or of that vector. Similarly, n minus 2 will give you the third last value of that vector. So the syntax for when you address even a 2D matrix, so this one we looked at was the vector. So when you're addressing a 2D matrix, you use the row index and the column index. So you always use the row index first and then the column index. So if we have A equals to, let's say, 1, 2, 3, and then 7, 9, 10. So if we want to find, so B equals to A, we want to find the second row and the third value, which means we want to find the value 10. So it will be second row and the third value, and that will give us 10. So when you address a vector, you just have it as whatever the index of that vector. If it's a matrix, you address it the same way, except that you need to specify a row and a column as well. So this is just an example of running with like a 2D matrix. So if you have the matrix A, and you want to find the value 6 and 9, so here we're specifying we want from the matrix A, we want the first row, we want columns 2 and 3. So that will give us 6, 9. Or the first row and columns 2 to n. So from the second until the n, which in this case will be 3. So notice here, there's another syntax here using the colon. So the colon means you want all the elements in that row or in that column. So for this case here, if I say A, and I open the bracket, I write 2. So 2 will mean the second row. If I write colon, it will mean all the elements in that row. If, for instance, I wanted all this, I could write A, so all the elements in column 1. So that doesn't matter then the size of the matrix, so it will give you all the elements. So you can extract all elements in a row or in a column using this syntax. So this is for a bit of thinking for you to do. So if you have a matrix A, so when you write commands B and C, now what I would suggest you do is try to think, like before you run it in MATLAB, what will happen in matrix B and C? And obviously then you test it in MATLAB to make sure you understand or to make sure you get the same answer. Because this is mainly for if in the exam you could get questions that you're given the matrix and you're given some sort of code and the question asks you what will the output be. So you've got to make sure you understand what's the n minus 1, what's the colon, etc. So at this stage, it's good because you can do that and you can self-check your answers on MATLAB. So these, again, just some examples of where we use matrices. So we looked before, it's mainly when you use photos and computer vision, they use a lot of images and therefore a lot of data. But otherwise, anytime you're doing like sampling or experiments and all, you end up with large amount of data. All right, so that's it.